Welcome. We're going to do a few problems tonight before we go off for the long weekend so that you have those. I will also do a couple more examples on Monday. So these are just a few examples from Lecture 18 of solving nonlinear inequalities. And really, we're not learning anything new in this process because we have done this already in the context of finding number lines and setting them up in our previous examples for graphing. So we're really just extending ideas that we already know. Okay, we did the first example, so I will skip it. Just to remind you of the process, the key is that you have to get 0 on one side of the inequality. That's the first thing. Then you factor to find the zeros. Set up your number line with the test intervals, choose a number, and then just look at it and see if it's positive or negative. And so we'll look at that. This first example is in your notes already and the video from class on Wednesday. So let's jump to this example. X squared is less than or equal to 4x. The first thing I have to do is write this as a polynomial less than 0. And what that does is it gives us a new polynomial. We're going to call it x to the 4th minus 8x. Okay? And then what we're going to do with that is factor that. Okay? And we get x. Now we have a cube. Little bit nasty. We have to go back to our remembering of how we factor cubes. Okay? Sorry about this. It's so annoying. Right? Does not want to focus. There we go. Okay. And if you remember the formula, it's going to be x minus 2 match, then its opposite, x squared plus just the product, 2x. You don't have the 2 in front of it like the square. And then it's always positive 2 squared. Okay? And that's less than or equal to 0. Now we have seen earlier, if you go back in your notes, we talked about this. We said this does not factor in the real number system. And I should point out that we're dealing strictly with real numbers here. For one thing, complex numbers don't have order. We can't talk about a complex number being larger than another. So we're just dealing strictly with the real number system. And so our zeros are just going to be at x equals 0 and x equals 2. Okay? And by the way, you can see that that doesn't factor. If you look at the discriminant, set it equal to 0 and try and factor it, and you would see that you're going to get complex solutions. Okay? So we only have 2 solutions, 2 critical numbers, and so we set up our number line just based on those 2 values. Okay? So we're going to have 0 and 2. And if you remember, we take a trial point in between. Okay? So what are we looking at now? We're looking at our f of x, which equals x to the 4 minus 8x. It's easiest, whatever form of it is easier to evaluate. In this case, it's easier, I think, if it's not factored to find the values. So we'll do that, and we use our trial point. How about negative 1, 1, and 3? Okay? And to save a little bit of time or space, I'm going to work that out down below. And f of x, remember, is x to the 4th minus 8x. So it's negative 1 to the 4th minus 8 times negative 1, which is 1 plus 8. Okay? And that is greater than 0. So I know that in the interval up to 0, that function will be positive. Okay? Then I use my trial point of 1, and I get 1 to the 4th minus 8 times 1. That's less than 0. So on the interval from 0 to 2, our function is negative. And then finally 3, I get 3 to the 4th minus 8 times 3, and 3 to the 4th is what, 81, minus 24, which is clearly going to be positive. Now notice that unlike graphing, I don't actually work out the values. I just want to know if they're positive or negative. Okay, I have that information, and so I can answer our question. Remember what we want to do. We want to set f of x to be less than or equal to 0. Okay, and so I look at my number line. Oh, that's going to occur between 0 and 2. Now the only question is, do I include the endpoints? Notice that the function is defined everywhere, so those values are in the domain. The inequality included in equals, so we have the closed interval from 0 to 2. Okay? Let's look at a rational inequality. A rational inequality is going to involve fractions. And the only difference with a rational inequality is that we have this extra step. Well, it's kind of a key step. Just like before, we have to have a 0 on one side, and we have to write as a single fraction. That's the key step. And then we find zeros of both numerator and denominator. Now we know that zeros of the denominator are not going to be in the domain, but they still separate our intervals, and they still allow for a change of sign. So we use all of those numbers, and then we solve as before. Okay? And so keep in mind this very important fact that the sign can change both at its zeros and its undefined values. So when we talk about key or critical numbers, it's zeros of both numerator and denominator. Okay? Let's do one. First of all, I'm going to do two. One is a rational inequality where the fraction is already written in the form that we want with the numerator and denominator on one side already. We have 0 already, so we're good. Okay. So then we have to find the zeros. Or actually what I should say is we have to find the critical numbers, which are zeros of the numerator and denominator. And let me go ahead and give this function a name. And observe that in its domain, x can't be 2. Okay? So 2 cannot be an answer, but it certainly can be a critical number. So we look first of all at zeros of the numerator. So we set that numerator equal to 0. And we get x equals -1 and x equals 4. And then we look at the zeros of the denominator. And that's where the denominator is equal to 0. And of course that's at x equals 2. It's not in the domain, but it is a critical number. And so when I set up my number line, I'm going to have all three values. I'm going to have -1, 0, 2, and 4. Okay. Even though 2 can't be in the domain. And you might want to like put a little circle there to indicate that it's not a possible choice. All right, our function f of x is given by this rational function. And so we want to know where it's positive or negative. So we do the same old routine. -2 here. Here's a value of 1. 3, and 5 for our trial points. And then I just do the same routine again. I plug them into the function. This time I'll use the factored form. So it's -2 plus 1, 4 minus a -2 over -2 minus 2 squared. It's -1 times 6 over what? Well, it doesn't matter. It's positive, but it'll be 16. And that is less than 0. And so it's negative on that interval. Okay? We try, oh, why did I put in 1? Let's put in 0. Make it easier. Okay? So we're going to find 0. It'll be -2 plus 0. I'm sorry. 0 plus 1. 4 minus 0 over 0 minus 2 squared, which is 1 times 4 over 4, which is clearly positive. Okay? Okay. How about the interval from 2 to 4? If we plug in 3, we get 3 plus 1. Again, we're plugging it into our function, which is 4 times 1 over 1. Notice that it is still positive. Why doesn't it alternate signs? Look at the power. X minus 2 is squared. There won't be a sign change because of that extra factor. Okay. And then for, you can check that out. What do we get? We get 4 plus 1. I'm sorry, we're plugging in 5. 4 was the endpoint. Okay, it's been a long day, so sorry about that. 4 minus 5 over 5 minus 2 squared. And I get 5 times -1 over 9, less than 0. Okay? And so this time it's negative again. And so what is our answer? We want f of x to be greater than 0, and this time it's strictly greater than. Okay, so I go back up, and what do I see? I see, oh, it's greater than 0 from what possible intervals? Well, notice that we go from -1 to 2. Now, do we need to split this up? You see we have 2 intervals where it's positive. The question is, do I have to split it up? Well, remember, 2 is not in the domain, so I cannot include it in the interval. So I'm going to go from -1 to 2. I won't include 2, and then from 2 to 4. Okay, do you see why I need to split that up? Because 2 is not in the domain. It's eliminated right off the bat. Okay, and that circle kind of helps me see that. And so then the only question left is, do I include -1 and 4? Strictly greater than 0, so I do not include those values. Okay, so you see the process, it's the same over and over. The key, though, is that you have to have 0 on one side of the inequality. Thanks.